All right, Gauteng people, let's have a look at what you wrote on the prelim exam for this year of 2025 on question 5. You had a function there, which was a parabola, a straight line, and also a logarithmic function. All right. So now, if you are from Gauteng, please give us a like and tell us where you're watching from. I know guys from Centurion, Midrand, Marlborough. I know guys from Northcliffe, Cresta. I mean, you guys, West Rand, East Rand, Springs, Kwatema. Guys, let me know. Give this video a like and let us know where you're watching us from, and we'll definitely do a question paper of where you are watching us from, or maybe send us a question paper from your school. Our contacts are on the details below, or you can also drop us your question paper from your school via WhatsApp. So let's have a look at this one. 5.1. 5.1 says write down the coordinates of the turning point. Okay, you would know that if you're given a function like that, you can either use x is equals to minus b over 2a, or you can use the first derivative is equals to 0. So in this case, I'm going to use the first derivative is equal to 0. So when I take the derivative of this function, I'm going to get 4x minus 1 is equals to 0, which is the first derivative. So therefore, I'm going to go ahead and solve for x. I divide everything by 4. Therefore, x is equals to 1 over 4. Now you go and take this 1 over 4, substitute it back into the original equation to get the y value. So therefore, when you substitute it, it's going to be 1 over 4 all squared minus 1 over 4 minus 15. Which gives me, in this case, minus 1 to 1 all over 8. Therefore, the coordinates of the turning point will therefore be 1 over 4 is to negative 1 to 1 all over 8. There you go. Right, those are the coordinates of the turning point. 5.2, it says here, show the x-intercept and the x-coordinates of the x-intercept of f are negative 5 over 2 and 3 respectively. Right, so they want us to show you the x. Remember, x-intercept, we get it when y is equals to 0. So in this case, this would be 0. Then you are left with 2x squared minus x minus 15 should be equal to 0. Therefore, we're going to look for the factors right here. 2x and therefore x. I think 5 will be here, then 3 will be there. There's going to be negative. This one would be positive here. This one would be negative. So therefore, our x value will be negative 5 over 2, or x is equals to 3. So now our x-intercept coordinates will be something like that. And then this one will be 3 is to 0. Great stuff. Okay, right, we managed to get that one out of the way. Right, so 5.3, let's not forget those numbers, guys. Let's move on. 5.3 says sketch the graph of g of f g h below. Clearly show intercept with axis and lines of asymptotes on the graph. Okay, so now what we'll do here is 5.3. Let's come here, state the functions that were given to us. F of x is equals to 2x squared minus x minus 15. Okay, and therefore g of x, let's note it down, is 3x minus 9 all over 2. And therefore h of x is equal to log 1 over 3x. Okay, so now let's just have a look. This graph, we haven't done anything on it. This one, we've got x-intercept, and then we also got the turning point right there. So now let's come here, do g of x when x is equals to 0. What will we have? We're going to have the x-intercept. Remember, this is a straight line, 9 over 2. So therefore that's what we're gonna have, and then you're gonna come here and say, okay, now when g of x is equals to 0, this is 9 over 2. When g of x is equals to 0, what is our intercept thereof? 0. Okay, so we take 9 over 3, x is equals to 9 over 2. Divide everything by 3, so we divide by 3. 3 is equals to, this 3 goes how many times here? It goes 3. So this side we're only going to be left with x. Okay, it's going to be 3 over 2. Okay, great stuff. So our x-intercept is just that, 3 over 2 and 0. Okay, great stuff. So now, as you can see here, this function right here, it's a logarithmic function, which is just the inverse of the exponents. So I would suggest that you draw the exponent of this one first, or you should know that the exponent of this one, just to show you guys, is gonna be 3 to the power that. So now with that in mind, you would know how to plot this one, right? Okay, so let's get a black color here, draw the Cartesian plane where we're gonna be drawing our graphs thereof. I'm gonna try to show as much as I can here for the sake of understanding for you guys. Okay, there you go. Right, great stuff. So I'm gonna show here 1, 2, 3, then 4, then 1, 2, then 3, then 4, then minus 1, minus 2, minus 3, minus 4. Okay, here we go. Okay, there we go. Minus 4. Therefore, let's start drawing by the parabola here. Okay, if we're to go back, parabola says here our turning point is 1 over 4 negative what? Okay, now we've got x-intercept at 3 and 1 over 2. So now 3 is here. Right, guys, you'll excuse me, I don't have a calculator here. So our turning point is 1 over 4 to somewhere there is our turning point. Somewhere there. And then the other one, it's here. Y-intercept. Okay, I'm sorry, this one, this scale is totally out, because somewhere here there has to be a 15 there. So I think somewhere here we'll just say this is our 15, negative 15 as our y-intercept for this graph of a parabola. So my scale was completely out there, but I quickly saw that and then I fixed it. And therefore this should be our function for the parabola. Not the best function in the world, but I think you guys get the picture, right? So now let's do the straight line. Straight line here says y-intercept is at minus 9 something. It should be somewhere here. Okay, negative 9.2. And then what else? Okay, x-intercept, it's somewhere right there. Right, so I'm gonna plot this one. Let me use a different color. I'm gonna use green to plot the straight line like we did previously with the other questions. There goes our green straight line. There you go. And then now we need to plot the logarithmic function. Right, guys, and you would remember with this one, if it was a straight line, it was gonna be like that, but touching here, not touching the x-axis. Now, because now it's a logarithmic, is going to be touching this point here, which is 1. It is not gonna touch the y-axis, then it's just going to be like that. let me see, just going to be close to there, then it goes all the way like that. So now this is the graph of h, this one is the graph of f of x, this is the graph of g, and that's how your functions would look like, guys. Right, so now 5.4. all right, 5.4 said if h is a point on G and R is a point on F, such that the upscalar of both points is 4, determine the length of HR. So this is actually the difference between 2 points, point H, which is sitting on G. Okay, let's just come this side and visualize it. Point H, which is sitting on G, and then also point R, which is sitting on F. Okay, so this is just 2 points sitting on these two graphs. So you would know, guys, from our basics, that if you've got 2 points, you just have to get the difference between the two functions, okay, which is simply going to be f of x minus g of x, just like that. So let's come here. We know what is f of x is 2x minus x minus 15 minus, it's going to be 3x minus 9 over 2. So therefore 2x squared minus x minus 15 minus 3 plus 9 over 2. Okay, let's go ahead and simplify this. We're going to have 2x squared minus 4x negative 21 over 2 when we simplify this, right? So now it says there, they said that if the x2 point is at 4, so basically what they are saying to us, they are saying that, okay, if these points are sitting at 4, so it means that x is equal to 4 here. So we're just going to substitute 4 here and just to get the distance between these 2 points here, right? So as I punch my calculator here, let's see, HL will have to be, I'm getting 11 over 2. I hope you guys are following. If they give you two functions and then they give you 2 points sitting on the same vertical point or horizontal point, and they want you to find the distance between the 2 points, just minus the two functions, right? Great stuff. So 5.1, which is this one here, says the domain of H, which is the inverse of the hyperbola, the inverse of the exponential graph. Remember, h of x was given by log 1 over 3x. So they want the domain of this. The domain of this, if you go back and have a look at the function, the domain, they're looking for the y values. All the y values all the way are included. So therefore, our domain will have to be y it's greater than 0 for all the values, such that y is the element of all real numbers. Great stuff. Okay, right, and then no, sorry. Okay, this is the range, guys. I'm making a mistake here. This is our range. Okay, this is our range. Okay, so domain refers to the x values. X values, we must say, for all the x values, all the x values, excuse me, is included. Sorry, I swapped the domain and the range. The range is greater than 0, and then that x is the element of all real numbers, refers to the domain rather. Okay, great stuff. I hope you guys are following. If you're not following, please let me know on the comment section below. Now let's move on to 5.6. 5.6 says determine the values of k if the roots of 2x squared minus x plus k is equal to 0. Okay, for real roots, the discriminant has to be equal to 0. Please, guys, I can't stress this enough. If it means you must go and cram this, when are the roots real, equal, 2 and unequal roots, please go and have a look at that. So now we are coming to say here, okay, b squared minus 4ac, which is our discriminant, has to be equal to 0. So therefore, we're going to put b here. B is going to be negative 1 squared minus 4 A is 2, and then C, it's going to be just positive k, all that 1 minus 8k is equals to 0, and then therefore we take we take 1 to the other side, 1 to the other side, divided by negative 8, divided by negative 8, therefore k will have to be 1 over 8. Great stuff. So with that said, let's move on to 5.7. 5.7 is to determine the maximum value of g of x minus f of x. Right. So we know the function g of x, which is our straight line, was given to us by x, 3x minus 9 over 2, and then you're going to say minus, in bracket, you're going to have 2x squared plus x. Okay. Come on. Okay. I already multiplied by the negative. Anyway, it's fine. Let's go ahead and just do that with the already multiplied by a negative or not. No, don't want to confuse you guys here. Minus 15. All close. All right. 3x minus that minus 2x squared plus x plus 15. Right. So now for maximum, okay, so we want a maximum here. Let's come here and then just simplify this a bit. Negative 2x squared, this plus that is going to be positive 4x. Okay, negative 50, negative 9 over 2 plus 15 is going to give me positive 21 all over 2. Okay. Great stuff. So now they want a maximum. So what are we gonna do here? Because they said the maximum. Whenever they say the maximum, you must always remember first derivative has to be equal to 0. This is what you have to remember. Okay, so we're gonna take the first derivative and then equal to 0. The first derivative here, 4x, right, plus 4 is equal to 0. Then you go ahead and solve for x. If you solve for x here, you're gonna get x is equals to 1. So now with this value of x is equal to 1, it must be substituted into the equation of the maximum, which is this one right here. Therefore it's going to give you a maximum value of 25 divided by 2. Yes, Gauteng people, that's how you would deal with a question like this one. Please let me know what you guys think right there in Soweto, Orlando, Protea Glen, Dobsonville. Let me know what you guys think of this one. Drop a comment and then I will definitely get back to you. If you understood, give this video a thumbs up, like it and share with your friends, your classmates and everybody that really needs it. For those of you who are rewriting, I hope you guys find everything in order in this question. Let me know what you guys think and I will see you on the next one. We will be doing question maybe from your province. Let me know which question you want us to do.